lectures, like, in the lecture portion of Canvas. All right, in the module section titled lectures, I'll put it there by date, and that's where I'll put it. Okay, so what I'm going to do is this. Remember, we left off with the addition rule for probability. Is that true? So what is, by the way, the addition rule for probability? What is that addition rule for probability? What do you guys think? Anybody know what the addition rule was? That's the probability of what? A or B equals what? Probability of A plus the probability of B, and then what else? Minus what? A and B. So here's A or what? Or B. Probability of A plus what? Probability of B minus the probability of what? A and B. Okay, you guys okay with that? So you're going to select what? A person. What does that mean, A? That's one person. And notice what I gave you guys to warm up with is all what? All or questions. What I mean by that is you got man, woman, man survived, or what is this? Boy, girl. Okay, you guys see what I'm saying? I gave you 4 warm-up questions to work on, and we're going to go over them. But I want to test you guys to see, can you answer or questions? You guys see my point? Can you use the what rule? Addition rule for probability. That's what I want to see. So here's that passenger. You're selecting a person. There it is. And that situation only should be of concern when what? You're dealing with the what? And. So I'm going to give you guys a hint. Okay, remember that. And. That word and there. So try this out. Let's see what you get. Here we go, ladies and gentlemen. Let's get out the clock. Where are you, clock? Oh, sorry. Clock is over here. And we'll give you guys some time to do this, okay? Hopefully you guys can do this. Of course, we'll go over it. All right? There you go. Okay. Okay, ladies and gentlemen, let's double check this here, okay? We were dealing with this rule. So the first question, what's the probability of selecting a man or a boy? Okay, remember to use this P of M or B, P of M plus P of B minus what? M and what? B. Okay, you guys remember this? So what's the probability of selecting a man, ladies and gentlemen? Go back to the table. Can you guys tell me? 1692 divided by 2,223. Good. Look at that, ladies and gentlemen. So this is my first probability value, right? If you look at the colors, they're asking you an OR question, and you just found the probability of selecting a man. It's right here. Okay, you guys okay with that? What's the probability? What'd you guys get for the probability of selecting a boy? What is it? 64 out of what? The 2,223. Okay. Now, what about the last question? Do you guys remember? Why do I always emphasize you're selecting a person being, you're selecting one person? Do you guys know why I always do that? Why do I do that? What do you guys remember about and? That person has to be a what? Man and a what? Boy. Can a person be a man and a boy at the same time? No. Say no. There's no such thing as a man-boy. All right? Okay, ladies, I understand. You might say, no, my man acts like a boy. There are no man-boys. All right, you guys okay with that? So what's that probability? Right off the bat. That's going to be what? 0 out of that 2,223. In other words, you have a probability equal to 0. It's impossible to select a man-boy. Is that right? You can't be both a man and a boy at the same time. So, ladies and gentlemen, what does this give you, right? Notice your denominator is the same. 2,223, 1692 plus that 64. So, 1692 plus 64, I'm going to go to a TI-84 calculator. I apologize. I'm going to do this all together. 1692 plus 64 divided by what number? 2,223. You might say, Mr. Judge, what do you apologize for? We're going to approximate this to the nearest what? Thousands. That's what we've been doing with the last examples, right? So 3 decimal places. So what is that going to be?
0.790.
Yes. It's 0.790 because it's 7899.790. So you're correct. What does that mean, ladies and gentlemen? 79%. Yes. 79% of the passengers were either a what? A man or a boy. Now let's be careful. Let's think about the importance of or. Or is important. Why do you guys think or is important?
One or the other or both?
Yeah, but if I said to you, what does it mean to either be a man or a boy? What does that mean about the person? if they're either a man or a boy, I'm not saying and because you can't be both. You're a man or a boy. What does that make you?
When you're a man, you're like, I guess, like more mature. A boy, you're a child.
It makes you a male. You guys know what I'm saying? So it's actually before all that. See, in math and logic, a man is really a male that's what? At least 18. A boy is a male that's under 18. So logically speaking, when they say, you know, because you might even say to me, Mr. Judge, why do I even care about being a boy or a man and all that stuff? Well, that makes you a male. So they can ask you a question, really in theory, what's the probability of being a male? Well, you just figured it out. 79% of the passengers on the Titanic were who? Were males. That's all. Okay, so you guys see how that language fits? 79% were males. What does it mean for question number 2, right? So for question 2, what did I ask you? A woman or a girl? Probability you're a woman or you're a girl here, okay? That's a probability you're a woman plus a probability you're a girl minus a probability you're both a what? Woman and girl. Okay? Now put the equal sign here because we ran out of space. Again, does the colors help you see everything? They do? Okay. Well, that's good. So, again, all right, and then this word here is what? And. Probability you're a woman, go back to that table here. What's that probability? 422 out of what? 2,223. What's the probability you're a girl? There's 45 girls. Yes, out of 2,223. Okay. Now, what's the probability you're both a woman and a girl? Remember, we're selecting what? One passenger. That's why I always emphasize that, meaning you got to be a woman girl. Now, again, there is no such thing as a person being a woman girl, meaning they're both. Is that right? You can't be both a woman and a girl. What's that probability? 0. So you say, okay, that's 0 out of 2,223. It's impossible to be a woman girl. You can't select a woman girl. There's no such thing. So that probability is 0. Let's see what we get now, right? 422 plus 45 divided by the 2,223. So I'm going to put that on the calculator again. TI-84, parentheses, 422 plus 45, close it, divided by 2,223. Next week, we'll have our computer back, ladies and gentlemen. I just got an email from Apple saying it's pick it up. So you might say, hey, today I can't see your calculator. But next time, what? You will. So what is this? 0.21 to the nearest thousandths? What's this going to be? 0.210, is that right? So you might say, what does that mean? What's 0.21? You can put 0.210. What is this? 21%. So 21%, ladies and gentlemen. 21% of the passengers on the Titanic were who? Women or girls. There's nothing interesting about that statement unless you realize they're who? Female. Okay? So the probability you're a female on that ship, 21%, 0.210. And that should make some sense. Why does that make some sense? 79% of the passengers were what? Men, and then 21% of the passengers were who? Women, ladies and gentlemen. I'm sorry, let me say it again. I made a mistake. It's been a long day. I'm multitasking with an email and lecturing and thinking about 3 different things. Like, man, Mr. Judge, you can quadruple task. You can quintuple task. That's my problem, my quintuple task. 21% were what? Female. 79% were who? Male. What do you guys think? Is that pretty good? Nice. That's the meaning of the word or. This is why language is so what? Important. People don't realize how important language is. If you want to be a lawyer, what should you specialize in? Language. Yes. Focus on language. Contracts are written in what? Language. Anyway, did you guys ever realize language is so important? Ooh. I think what you should do, and if I was a president of the world, or you would read, write, and do arithmetic every day of your life. Read, write, and do arithmetic. None of the nonsense that goes on in high school these days. What do they have you doing? Who are the recent high school grads? I remember my daughter, you know what she took? Leadership. You know what I told her? What are you doing in leadership? I got to show up early for school. And I help set up for this thing, and then after school I set up for this, and then I got to go to this fair, and I got to work and do this. I go, that's not leadership. You're a slave. You're working for free. If you want to work for free, just wash the dishes. You can do that at home. Leadership? That's not leadership. You guys know what I mean? And then she took choir, and there's nothing wrong with singing. You know, you may say, Mr. Joe, what do you have against singing? Nothing. She was also leadership in choir. Again, what did she do? Oh, she had to go visit the trustees and go sing to them. What would I rather do? Besides wash the dishes? Because I had to wash the dishes. Read, write, and do what? Arithmetic. When she left high school, you know what she said? Dad, you're right. She now says I'm right about everything. I'm like, I know, Ashley. Should have listened to me. Isn't that amazing? That's what starts to happen. Sometimes you'll realize how right your parents were. Sometimes maybe not. Anyway, just thought I'd share that with you guys. What's the probability you're a man or you survived? Let's try that one out. Probability you're what? Probably a man or you what? Survive. What does that equal? Probability you're a man plus the probability you survived. Right? You guys know what I mean? We've done this stuff. Man. Probably you're a man and survive. I ran out of space. Okay, what's the probability you're a man? You guys know that already. 1692 over 2,223. What's the probability that you survived?
706.
Yeah, let's look at the table. Surviving. Oh, 706. You're right. Good job. Okay. Out of 2,223 minus, hey, can you be a man who did both?
Yeah.
Let's see. Remember what I was saying here? Where is it? Ah, we got to go back to that stick figure. So what are you again? You have to be both a man and you got to what? Survive. So you can be both man and what? Survive. Remember, you got to be both. What is this really known as? You're a man who survived. Is that right? So you say, okay, where are the men? Right here. We're the ones who survived. Right here. This intersection is where they're what? Where you're both. 332 men survived. You guys remember we went through that last time? 332 out of how many? 2,200 and what? 23. Remember that was our sample size? Easy peasy lemon squeezy? Okay, 332 over that sample size. All right, let's see. Okay, ladies and gentlemen, what are you going to do? You're going to punch this in the calculator, is that right? Notice how I punch it in. Parentheses. What was that first number? 1692? Plus, what's the second number? 706. Minus, what's the last number? 332. Close that. Divide by 2,223. Oh, what happened? What did I touch? Okay. Can I go back? Can I? All right, let's try it again. Sorry. I don't know what I touched. 1692 plus 706 minus, what was that number? 332. Parentheses divided by 2,220 what? 3. What do you get? 0.92 what? 9. 0.929, ladies and gentlemen. 0.929. What does this mean? 92.9% were either men or what? Or they survived. Because that's the question here. It's not very interesting in some ways. Okay. Well, let me go back. Why am I doing blue? Not very, come on. Being a man or a survivor, you know, is really, there's no real meaning, right? You're a man or you survive. That's it. Probably you're a man or you survive. It's not like saying you're a man and you survive. But the point I want to make is don't ever think that this probability over here is always 0. Okay? This is not always what? 0. Do we see the deck of cards? Remember the deck of cards? Was that always 0? No. It's not always 0, ladies and gentlemen. And then what's interesting about 4? Was the last one interesting? Why is the last one interesting? Let me share with you guys. Why is the last one interesting? Number 4 here. This is the or. Probability you survive or you died. That's an interesting kind of thing in some ways. The addition rule says that's a probability you survive plus the probability you died, minus the probability you survived and died. Okay? So let's go through it with colors. I'm sorry I didn't do it with the last example. Orange, green. You're going to have to get those individual probabilities first because this, again, is an or question. And then don't forget, survive and what? Died. Okay? So what's the probability you survived? Go back here. Oh, it's a wrong color, but whatever. We'll change it. This is a probability. How many people survived on the Titanic? 706. Good. Out of 2,223. Good. What's the probability you died? And you got to go up here now and find the died row. Oh, there is a died row. What's that probability? Well, 1517 out of the what? 2,223. You guys okay with that? 1517 out of 2,223. So, ladies and gentlemen, okay, good. Now, what minus the probability you did both? So, can you do both? Right? Go back to that single passenger. That passenger did what? Survived and what? Died. Be careful. Can you do what? Both. Can you survive and die? What do you guys think? No. What's that probability? 0. 0 out of 2,223. This event is impossible. Did I give you that definition? Check your notes.
1.
The probability is 0. What does it mean? It's impossible. Is that right? Okay, good. So how do I finish off this question? I just have to what? 706 plus 1517 over that what? 2,223. So, ladies and gentlemen, let's do some arithmetic. Okay, oh, let's go back. 706 plus 1517, close that, divided by 2,223. Come on. What's going on? 706 plus 1517, close, divide 2, 2, 2, 3. What do you guys get? What does that equal? Can you even see that? That probability equals what?
Certain.
1. Yeah, the probability, if it equals 1, any probability that equals 1, that is what? That's equal to what? What does that mean about the event?
Certain.
Good. It is certain that you either survived or you what? Died. Does that make any sense? It's certain that a passenger on the Titanic either survived or they what? Died. I know it seems silly, but it's not. It's practicing that language. Okay, so you say passengers either survived or died. The chance you select somebody at random and you ask, what's the probability they either survived or died? Well, it's certain. It's 1. Probability is 1, but any probability that equals 1 is certainty. Is that true? Okay, you guys okay with that? Easy peasy, lemon squeezy? Did I give you the definition last time of not likely? Almost certain?
Yes.
What do probability values live between?
Less than 5% or above 95%.
Generally speaking, probabilities live between what two numbers? Did I give you guys that? Probabilities. I don't see any definitions. I'll give it to you now, though. Okay? Or I'll give you guys this fact here. Give you a couple of facts. Let E be an event. You know what that means? 0 less than or equal to P of E less than or equal to 1. So what am I actually saying here? You guys know what I'm saying? Probabilities are between what two numbers? 0 and 1. I can actually prove it to you. You guys mind if I prove it? I can prove it. You guys ready for that? Go, Mr. Judge. 0 is less than or equal to n of e, which is less than or equal to n of what? S. Okay? Now, do you guys remember what I drew for you guys last time? What did I draw for you? I drew a Venn diagram. Is that true? So you might say to me, how do I know this kind of relationship, right? If I go to a Venn diagram, remember, you're looking at really what we call the universe. Is that right? What's the universe? It's a set of all the outcomes. This is a set of sample space. So if I do this, big E, ladies and gentlemen, these are all the outcomes that are in E, okay? Notice, what does this inequality say? That the number of outcomes that are in E is smaller, is less than or equal to the number of outcomes, generally speaking, in the sample space. And that's actually bigger than 0, greater than or equal to 0 here, okay? So you're really looking at, logically, a significant picture. And then now I would say you get to use some algebra. You know, the topic that some people say they do not need. Anyway. Okay? By the way, I'm going to remind you guys, am I going to be here on Monday?
No.
Good. Am I going to be in Maui on Monday?
No.
Thank you. Would I rather be in Maui on Monday?
Yes.
Good, you guys are listening. I like that. So yeah, I'm not going to be here. Okay, you guys okay with that? I'm not playing hooky, but I'm not going to be here. 0 is less than or equal to, what's n of e over n of s? P of e. What's n of s over n of s? 1. You guys know you just looked at a proof here in math, and you use a little bit of algebra, because remember, when you divide both sides by a non-zero, well, you divide any inequality, 3 sides, and the number's positive. The number of outcomes in a sample space is positive, by the way. It doesn't change the direction of your inequality, so it's 0 less or equal to P of e less or equal to 1. So what if you get a probability value of 7? What does that mean? You get a probability value of 7. They put a new computer. Where am I going to put my laptop? Okay, I'll figure it out. Probability value of 7. What do you think that means? You did something wrong. Good. Probability value of -2. You did something what? Wrong. Probability value of, I don't know, 1.9. You did something what? Wrong. 1.5. Wrong, because where do the probability values live? Between 0 and 1. Okay, you guys okay with that? Easy peasy lemon squeezy? No? What do you guys think? The addition rule for probability has you answer what kind of question? The or question, is that right? Okay, ooh, I almost fell. Felt like I was gonna fall, but. Ooh. All right, you guys good with that one? All right, good. Now, here's what I'm gonna do. I'm gonna teach you guys a few important ideas today, very important. But I'm gonna look for my bag of marbles, and you want to know something? I don't find them. I think I screwed up. So I don't know what I did. I might have deleted that whatever, who knows? So I want to ask you guys, remember our bag of marbles? Okay. Tell me what was in our bag of marbles, right? I'm going to put this here. Bag of marbles.
8 red,
How many?
8 red,
8 red. What else?
5 blues,
5 what?
blue,
5 blue.
6 yellow,
6 yellow.
2 green,
2 green.
1 orange.
And 1 orange. Now, okay, I'm going to color coordinate the color whatever. Red, blue. And I'm going to ask you guys a question now. Again, I'm going to use a little bit of language. I'm going to say you select a marble at random, okay? So that's what's going to be. You select a marble at random. What's the probability of selecting question 1? A non-red marble. Question 2. A non-blue what? Marble. And then question 3. What about a non-orange what? Marble. So let me do something here. What does every one of these questions have in common? Non. How about a non-green marble? Non. So let me go through the details here for you guys, okay? Should we have you guys try this out? Okay. Should we have you try it out? What does the word non-anything mean? Not that. Good. Not red. Not blue. Not orange. And then not what color? Green. Okay. We're going to give you guys some time here. Let's get out the clock. And let's see what you guys can do with your probability definitions, okay? All right, we'll see what you guys can do. Hold on. You guys okay? Okay. It's weird. Anyway. Okay. You guys ready to try this out? What this really is about, again, you have to know for question 1, we're going to use the definition of probability. We have to know what it means to select a non-red marble. So tell me, what do you guys think that means to select a non-red marble?
Everything but red.
That means everything but what? Red. Okay, does that make some sense? So if I said to you, you know what's not red? Blue, yellow, and green, and orange. Is that true? How many marbles are not red then? Well, I forgot how many marbles we had in the bag anyway.
22.
We had 22 marbles? Okay. All right, so if 8 are red, aren't the rest non-red? What does that mean? What does that equal? 5 and 6 are 11. 11 plus 2, 13 plus 1, 14. So this is going to be what? 14 out of what? What's 14 out of 22 reduced? 7 over 11, ladies and gentlemen. And ladies and gentlemen, probability of selecting a non-red marble is 7 out of 11. You're using the definition. You're really not even counting, are you? You notice you're not counting. You're just reading your table. Yes.
So when do we know when to have a fraction answer or a percentage answer?
Yeah, that's a good question.
Just whenever you specify?
I guess. Yeah. But really, the real answer is, in all honesty, you're going to see, like, when the fractions are easy to simplify, you give a fraction answer, in all honesty. But that's a loaded kind of thing to say. Because you might say to somebody, hey, simplify 5/10, that's easy. And they go, I have no idea how to simplify a fraction. Look at the Titanic. You don't want to simplify those fractions. They're big numbers. So the general really thing to say is if they're big numbers, simplify, use the decimal representation. If they're smaller numbers like marbles or having children, then you notice, oh, he actually wrote a fraction. But generally speaking, you're right, Anyway, okay. I don't know, kind of answers the question. But what I do is I try to tell people, hey, approximate, on a test, approximate to the nearest thousands. I typically say thousands. Some things are like, z-scores are always the hundredths, So there is some tradition for some, but anyway. Probability of a non-blue marble. Definition, number of non-blue marbles out of what? Total in the sample space. So I'm going to have to go back and I'm going to have to ask you guys now again, which marbles are not blue? The red, the yellow, the green, and the orange. Is that right? How many marbles are these? 8 and 6 is 14, 15, 16. Oh, good. 17 out of how many? 22. And ladies and gentlemen, you can't simplify that. And so what does that mean? That's your answer. There we go. And by the way, I want to give you guys a definition so you guys know here. The definition of what we call the complement of an event E. Okay? That's E. Well, it has notation. E with a line, E with a prime. I put the phrase non-E. That is defined to be the outcomes that are not in E, but are in what? S.
How do you write the second E?
That's with a prime. Actually, what I'm doing is notation. Like some books, this definition is the complement of an event. So in some books, they put E with a line. Some books have E with a prime. I just use the language version, non-E. Because to say a complement of an event, it's the things that are not there, but they're in the sample space. So you might even say to me, are all of these questions complement questions? Yes. You're going to see why that's important later. So when you go to question 3, and you go, okay, what's that question? Probability of a non, you're selecting a non-what? Orange marble. You might say, they're asking me a what? Complement question because of the word non or not. You know, the word non is an important word, or I should say, I guess it is a word. Not is important. Non is important. If I say, do not do that, is that important? Do you see what I'm saying? Not, no, non. So a non-orange marble means what? It's every marble that is what? Not orange. Do you know the meaning of a non-orange marble in this context? Everything but being what? Orange. You guys okay with that? That word non is important. What does that mean? All the other marbles but what? Orange. The 8 red, the 5 blue, the 6 yellow, the 2 green, those are not orange. How many marbles are not orange, ladies and gentlemen? 21 out of 22. Guess what you just did? You answered a probability question. In fact, it's a complement question. Okay? Probability of non-orange. There you go. Okay, now question 4. Question 4. Non what? Green. What's the probability of a non-green marble? Non what? Green. So that's the number of what? Non-green marbles out of the total. So how many marbles, ladies and gentlemen, in this bag are not what? Are not green. Right? You're everything but being green, okay? So you say, okay, what's not green? Well, the 8 red, 5 blue, 6 yellow, 1 orange. How many marbles are not green? Be careful. How many are not green? 20. 20 marbles are not green. Is that right? 20 out of what? 22. What does that reduce to? 10 over 11. They're both divisible by 2. And then the 10's divisible by 2, but not the 11. You have simplified these fractions. So, ladies and gentlemen, communication is extremely important. If I said to you, guess what? Mr. Judge is not a Republican. Okay, he's not. Bless you. What does that mean? No, not necessarily.
That you're anything but.
I'm anything but a Republican. What does that mean? Doesn't mean I'm a Democrat. I could be a libertarian. I could be independent. I could be a socialist. I could be peace and freedom. I could be Green Party. Is there anything else?
Brown party?
Huh?
There's a brown party? Isn't that one too?
There's a brown party?
I thought there was. Or maybe I'm making.
Who knows? I have no idea.
I thought there
I never heard that one before.
was. Okay, maybe there
I never heard that one before.
is. Let me see.
Yeah, exactly. What's the point I'm making?
Not Republican.
Non-Republican has options. What if I said Mr. Judge is not left-handed? What does that mean? I'm right-handed. Good. What direction is not up?
Side.
Non-up. You go, what do you mean? What's non-up? It could be going to the right, left, down, anything but what? Up. You guys see my point? It's important to understand that word non. Just like or, just like and. Those 3 words in probability exist, and it's a fundamental thing, but people miss it. I'm like, oh man. What does it mean if you're not hungry? Does that mean you're full?
No.
Mm-mm. It could be you're full. It's not hungry. You guys see what I'm saying? Yeah, what does not hungry mean? Not hungry doesn't make sense. Huh?
Not interested.
It's just anything but hungry. Yeah, you're not hungry. Has anybody asked you that kind of question? Are you hungry? And you say, no, I'm not hungry. Sorry, it's been a long day. Long day of triple tasking and quadruple tasking. This is complements of events. Now, remember that Venn diagram I drew you guys? Guess what? What I want to talk about today is something extremely important in probability, because if you ever see the complement, ladies and gentlemen, we have something special. We have something known as the complement rule for probability. Okay? I'm going to write this rule down for you guys, and then I'm going to prove it if you want me to. This seems, well, what am I saying? The probability of an event plus the probability of the complement of the event, what does that equal? That equals 1. Okay? So everything here in E, I'm going to share with you guys another important idea. What are you when you're out here? In that region. Anybody know what region this is in our Venn diagram? Altogether, it's the sample space. Every dot is an outcome. The one in the region E, well, they're in E. What are you in pink? Huh? You're not in what? E. All these outcomes are not in E. They're still in the sample space, but they're not in E. Would you guys agree with that? Okay. Let's count. You say, what do you mean? If I count the number of outcomes in E, and I add it with the number of outcomes that are not in E, what is that supposed to equal? The total in the what? Sample space. You with me on that? Doesn't that kind of make sense? Picture's worth 1,000 words. All right, I'm going to use a little bit of algebra again. Here's the algebra, you know. Yeah, it's kind of funny, that assembly member who said, I've never had any use for algebra in my life, but I have a lot of use for statistics and data analysis. I was an expert in it. Like, really? I doubt that. Let me show you what I'm talking about, though. Remember from algebra, you can divide both sides by any non-zero number. It doesn't change that equality sign. On the left side, you know what we use? The distributive property. Oops, excuse me. Distributive property. Okay? N of E over N of S plus N of not E over N of S. What's N of S over N of S? 1. You guys okay with that? Any number divided by itself is 1. X over X in algebra is 1. Do you guys recognize this anywhere? What's this? See that definition? Isn't that the probability of E? You recognize this definition? What's this going to be? Probability of not E. You okay with that? And there is your proof, ladies and gentlemen. The statement I gave you guys. This is known as what? The complement rule for probability. Now, you might say, how do I use this, right? Well, you know what you can do? Subtract both sides by P of E. What does that equal? That's what? Probability of non-E is 1 minus the probability of E. Algebraically speaking, I can subtract both sides by P of E, and I get the complement rule for probability. I get a formula, ladies and gentlemen, and this here is how we're going to use the complement rule. So I'm going to illustrate to you guys how this is done, okay? It's very simple here. And you guys want to do this, even though I know you could use the definition. I already know because you guys have been doing it. But I want you guys to use this complement rule because later on, you know, it makes everything easier for you to do. Formulas, like think of the addition rule. Using the addition rule is going to make an OR question easier. Don't try to do it without it. Complement rule is the same thing. So if I go back to the first question, you say, what was the first question? Probability of non-red? Not red? You guys okay with that? Non-red. Okay, probability of non-red. Isn't that 1 minus the probability of being red? Where what you need to do now is focus on this probability value. But don't forget, you are going to take the number 1 and you're going to subtract the probability of being red. What's the probability of being red or selecting a red marble? Go to the bag. 8 out of what? 22. Let's get rid of all of this. So you say, oh, is that going to be 8 out of 22? Yes. So, okay, let's do this here. 8 out of 22. You see the number 1. What could you replace that with? 22 out of 22. So we have 22 minus 8 out of 22. What's 22 minus 8? Can you simplify that fraction? 2 goes into 14 how many times? This is 7 over 11. Is that the answer you got using the definition? I think so. Isn't that the answer you got using the definition, ladies and gentlemen? 7 over 11. You guys got that answer. Easy peasy lemon what? Lemon squeezy. What about number 2, the probability of selecting a non-blue marble? How do we use the complement rule? Let's try that again. This time we're going to use what? Probability you select a non-blue marble is 1 minus the probability of selecting blue, okay? What's the probability of selecting a blue marble? You got to go back. How many blue marbles are there? 5. 5 out of what? 22. Is that true? Okay. So we go. You're going to replace the number 1 with what? Do you guys remember how this is done? Remember, you're subtracting a fraction from a whole number. So that number 1, you need to do what? 22 out of 22. What is that going to give you here? 22 minus 5 out of 22, which gives you what? 17 over 22. And ladies and gentlemen, is that the answer you got before? Isn't that the answer you guys got before? I think so. All right. Have you guys starting to get some faith into this formula? You go, okay, let's try number 3. Get a little faith. Non-orange. Let's verify this is what we got earlier. What does the complement rule say I do? I take 1 and I subtract the probability of selecting a what? Orange marble. Okay? You guys see what I'm saying? I know there's 22 marbles. How many marbles in the bag? Because remember, what are you doing? You're focusing on this. Probability. How many marbles are orange here? 1. 1 out of what? 22. So, okay. 22 out of 22. Anybody get this here? What's this going to be? 22 minus 1 over 22. What does that equal? 21 over 22. Is that right? All right, ladies and gentlemen, what do you guys think? Can you believe in the complement rule a little bit here? Let's do this. I'm going to look for our deck of cards. There we go. Standard deck. Ace is high in this question here, okay? Let's test you guys. Again, you select a card at random. What's the probability? And I'll give it the title, right? A standard deck is where you throw out the jokers. Is that right? What is it? Where's the ace at in this picture? High. It's above a king. That means ace is high. If it was below the 2, ace is what? Good. Okay, you guys okay with that? Not a problem. Okay. You select a card at random. What's the probability of selecting question 1, a non-ace? Question 2, a non-spade. Question 3, a non-ace of what? Spades. Question 4, a non-red card. And question 5, a non-red ace. So these are like all the questions I gave the prior class. Now notice what they are. Non. Those are all what kind of questions? Complement questions. Good. What do you think they want you to do? Use the what? Complement rule. Okay, they want you to use this right in here. All right, we're going to give you guys some time to do these yourself. What do I mean by that? Give you guys some time. Okay? See what you get. Would you call it like a is it more associated with a college algebra? Okay. Okay, so let's say this again. How would you define math analysis? Extended algebra 2, quicker pace. That's math analysis. So that's like a prereq for calculus. Interesting. So pre-calculus is math analysis plus trig. And that's also a prereq for calculus. So they're both prereqs. But math analysis has no trig, is that right? Interesting, only algebra. Okay, what about integrated math? What's integrated math one? Yeah. Mm-hmm. Okay. What about integrated math two? Mm. Okay, what about integrated math three? So it's algebra two plus integrated math three, algebra two plus what would that be? So that's generally a pre-calc course? Okay. Interesting, but because there is a category, integrated math three. They go to pre-calc after integrated math two. Where do they go after integrated math one? Oh, IM two, but integrated math two, they go to pre-calculus. Integrated math three, you're saying is pre-calculus. And where do they go after that? Hmm. Okay, not necessarily AP calculus, but calculus, right? Do you happen to know what integrated math four is? Okay, interesting. But integrated math three, I'm gonna go over that again. You're essentially saying it's a pre-calc course? Okay, so it's essentially, okay. Where can I go, do you know where I can go, like a website to read all that curriculum stuff for locally Alley USD? Cause I tried a little bit to look for it and I couldn't find it. Yeah. Yeah. Who would have that information, do you know? Yeah, probably have to call a high school counselor or a high school teacher. Right. Yeah, integrated math definitions, 1, 2, 3, and 4, and like I said, I wanted to look at really what math analysis is and pre-calculus. And pre-calculus has math analysis plus some trig, right? And then you also have a trig course. Mm. So okay, so you're saying in that year, they have a half a year of trig and then a half a year of what else? Math analysis, I see. And the order can change. All right, man, so thank you so much. I'm gonna try to send an email about it, because I've been asked, and I'm like, I don't know the difference between pre-cal and math analysis. You know? All right, yeah. All right, man, thank you. Do that as soon as you can, because the district's calling me about it, and I'm like, I don't know what integrated math is, 1, 2, 3, or 4. So I have to try to locate it, and I can't find it online. It's like LUSD buries all that, you know? I was gonna go back to how it was. Okay.
I can just look at it. There's something that's hard to look in there.
Yeah, it just everything's a fall.
All right, I'm gonna try to, I may call you later just in case I wrote down some notes, but, if you can find anything, let me know. And I'll send it. Okay, thank you. Sure. Bye-bye. Okay, ladies and gentlemen, you want to go over these now, or do you want to take a break? What do you guys want to do? You want to go over them now before your break? Oh, these answers are getting to you, huh? Good, ladies and gentlemen. Let's try this out. Okay, probability of a non-ace is 1 minus the probability of an ace. What's the probability of an ace?
4 out of 52.
Good job. Okay, so if this denominator is 52, what do I replace the 1 with? 52 out of 52. So I get 52 minus 4 out of 52. What does that give you? So 48 out of 52. So are they both divisible by 2? Are they both divisible by 2? And ladies and gentlemen, divide both numerator and denominator by 2 and you get 12 over 13. How many people got this answer right? Okay. Number 2, the probability of a non-spade. 1 minus the probability of a spade, and what does that equal? What's the probability you select a spade?
13,
Out of
52.
52. What does this equal? Let's see, replace the 1 with the 52 over 52. Is that true? 52 minus 13 over 52. And what does that give you?
39.
39 out of 52. So, ladies and gentlemen, do you guys know both of these numbers are divisible by 13? Or 3? Sorry. They are. 13 goes into 39 how many times?
3.
13 goes into 52. 4. So your answer is 3 what? 3/4. Okay, you guys okay with that? What's the next question? A non-ace of spades. So, probability you select. This is question 3. A non-what? Ace of spades. Now, that's going to be 1 minus the probability you select a what? Ace of spades. What does that give you? What's the chance that you select an ace of spades? Do you guys have to look at the deck? What's an ace of spades? It's a card that's both a what? Ace and a what? Spade. Is that true? Where is it? It's the ace of spades. How many cards are ace of spades? 1. So, ladies and gentlemen, you're going to say 1 minus what? Or 1 minus 1 over 52, because remember, this is a chance you select a what? Ace of spades. Now, what does the arithmetic tell you? What do you guys do now? What does the arithmetic say? Anybody know? This is what? 52 over 52. And we get 52 minus 1 over 52. You know what this equals? 51 over what? 52. Did anybody get this one okay? Okay, you guys okay with that? Is it getting easier? I hope. And number 4 now. When you say, what's number 4? A non-red card. Okay. The probability you select a non-red card. Isn't that 1? Mine's the probability of selecting a red card. What's the probability you select a red card? 26? What is that? What do you guys mean by that? Do you guys know which cards are red? The 13 hearts, the 13 diamonds. What does that give you? 26 out of 52 pickup. Is that true? Okay, what do you replace this 1 with? 52 over 52. Isn't that 1? So I have 52 minus 26 over 52. What does that give you? 26 over 52. What is 26 over 52? You guys know what I'm saying? Isn't that 1/2 as a final answer? Okay, you say, Mr. Judge, I want to do what you're doing. 2 goes into 26 13 times. 2 goes into 52 26 times. And then what do you guys notice? Both numbers are divisible by 13. 13 goes into 13 once. 13 goes into 26 what? Twice. Final answer is what? 1/2. This again is a what kind of question? What does that word non say? Complement what? Rule. Non-red ace. Number 5. Probability you select a non-red ace. Now remember, the complement rule actually makes this what? Easier. You may not think so, but let me show you what I mean. The chance you select a non-red ace, this is the event they're talking about, right? It is always 1 minus the probability of that event. You're going to do a little bit of arithmetic, but you're going to have to find the chance of selecting a what? This is my point. In gray, that probability should be easier. In fact, in gray, that probability should be easier. Okay? In gray, that probability should be what? Easier. In gray, that probability should be what? Easier. And then in gray, that probability should be easier. And that's the point. So all of those are just regular what? Probability questions. Okay? Those are the regular ones that we've been answering and going over. So if I said to you, what's the probability of selecting a red ace? What do you guys do? You got to go back to the what? The sample space, and you got to find. Well, let me do that. These are the red cards. Is that right? Where are the aces? Are these the aces? Which ones are the red aces? Ace of hearts. What else? The ace of diamonds. How many are they? 2 out of 52 pickup. Is that right? So this is my point. That should be what? An easier probability. But the price you pay is a little bit of arithmetic. Replace the 1 with what? 52 out of 52. Okay, and what do you end up with? Right? You're going to end up with what? You're going to get the what? 52 minus 2 over 52, which is going to be what? 50 over 52. Can we reduce that easily? Aren't they both divisible by 2? 25 over 26, and you can't divide both of these numbers by, by a common number, and now you're done, ladies and gentlemen. So just to kind of throw that out there, ladies and gentlemen, this is how we use the what rule? Complement rule for what? Probability. Let's take a break. Let's take a break. We've been working hard, right? Is it just me who's sweating? All right, we've been working hard. Let's come back. I can't even see my clock. Is that even right? We'll come back at 2 what? 2:10. We'll take a break, ladies and gentlemen, okay? All right. I'm going to write this email.
I think so.
There's no like a lot of fighting, so it was more pretty simple.
I'd say like my first year, 2010, we were still good non-fights. Maybe a little bit in 2011, but 2012 on, that shit didn't really happen at all. Barely, but besides that, I don't know, just thought the teachers were pretty fucking cool all around.
Did you have, I swear, I'm pretty sure this is probably the only teacher back then, but his name was Mr. Mo. Mr. Mo.
Yeah, I didn't have him, but I knew a lot about him. Is he the, oh, the Asian guy? Yes, I did have him.
Yeah, he just retired.
Really?
When I finished my senior year, he retired. He's been there like a while. I've known him since like my cousins also were like 14, 13.
Yeah.
So you've never seen him?
What do you mean you never seen him?
You've never like had him on your.
I actually fucked up. I was thinking about that older white guy who like taught like soldering. He was in the class. But anyways, I did have Mr. Locke for help. I mean, he was nice and I liked him, but one day he did kind of piss me off. I asked to use the restroom. He made me feel like shit about it.
Yeah, he always does that. I fell asleep in his class and he's just like, he insulted like the whole class. It's just like,
I agree with you, man. Can't let your kids walk all over you, especially when you've been there that long. Have to push your foot down there. Anyways, I had a, was Miss Christiana still there, your English teacher?
no way, bro. Yeah, she's still there.
She was there, she was awesome. She's a little badass, too. I really talked to her around.
Like things like that, I felt bad, but honestly, I was like, go and leave it, trying to go get some chips. She's like, okay, come out. I don't really have
She was sick. I fucking would watch movies in her class and on our laptops. She knew, but like, I got my own thing. She was a big fan of films too. So was I at the time. I still am. So we kind of chatted it up with that.
Yeah, she's still, like, by the end of the year, she just did like so much. We watched Sandlot, we watched like some of his movies, but
Is she still put on Cinema Paradiso?
I think she did do it last week. But yeah, she does that.
Remember, the 11th grade history teacher, the Asian guy, sells popcorn.
Shit. Oh, yeah, I know who you're talking about. I haven't seen it because COVID like cut me off.
For sure.
Yeah.
Because there's still that ongoing like theory that he's an alcoholic along with the theater arts teacher. That's cool.
Crazy things came out, but there was also this other guy, Tyler First, he's like a national teacher for, it's not, he did economics, but he also did government. I don't know if you know what I'm talking about. Mr. Kim. Is that your name?
I think that's who I was talking about.
Is it?
He was the history teacher.
Yeah, yes,
Maybe
yes.
I can see him.
You know, because there's two now, okay, I don't know if that's so early or so late, but there was another thing that came out where somebody found a picture in Las Vegas having a good time. It was just a bunch of strippers and
It was just,
it was hilarious to see it. And I remember somebody showed it to me.
this is weird. That's out of a movie. It's fucking sick, dude. How did you find it?
I honestly, I did not know what the hell it came out of.
Damn.
hard to get that.
show you how to do the odd numbers. The link is just like the video solutions, the actual worksheets are not.
Yeah, sometimes when the same thing does.
Okay. Yeah. Can you hear me? All right, I'm gonna do it again. Integrated math two, geometry plus a little bit of algebra two. It leads you into integrated math three, which is algebra two. And that leads you into the pre-calculus course. Okay, all right, thank you.
So they found out, that's what she was like, machine learning, was like,
Yeah. That's algebra two.
Put an arrow suspended for the.
Okay. All right.
I just didn't see it in the next week, what's going on.
Okay. Okay. Hmm. So, okay, let's see, integrated math two, it's some algebra two? Some geometry. Algebra, so you can say algebra two, some algebra one, plus some algebra two. And that leads you into integrated math three, right? And integrated math three is essentially algebra two. Okay, and then that leads you to a pre-calculus course after IM3. Okay, I think I got it.
Honestly, there's not gonna be a lot, at least I don't know if it was.
So I mean, yeah, I'm telling you, they hide them. I can't find them. Tell me, that's why I'm like going crazy. I can't find anything online. It's like they hide them. I'm telling you, they hide it. So I'm just trying to get the.
I'm surprised anyone has a balls to even bring it up.
You know, imagine the cauliflower ear, obviously, I didn't even know that was. Yeah, that's the.
Lots of respect to that guy, man. He's doing so much now, especially for this allegation.
Jesus, the amount of like, garage, honestly, mine is all like, it's like been the most physical violence since I've had like, straight up. I'm not gonna count anything, 32 or 33 different fights in 1 year. And it was my senior year. It's either a freshman or two freshmen or now, but this, like, Coach 2 periods that I had. And so Mrs. C was like, hey, help, sorry to break it to you, but there's no fourth period. I was like, oh.
Nice. I wanted it.
Yeah.
I wish there was.
You have a good view, you can see the house out there. That was it.
Is Mr. Green our teacher still there? How can you say that? I was there the first year of the game. It's kind of like geek black culture, which I thought was, because you still do all those, Halloween costumes. He's faulty art from bringing that. Yeah, he did. He had a jumpsuit. Another year he was, Ace Ventura, he had like the 2 people on, it was crazy. I really like that guy. I miss Martinez. Martinez Smith. I miss Martinez. I was a freshman and I was Spanish. I took Spanish here and she wasn't. My English teacher sophomore year was Miss Lomel. Biggest question. She was really good. Anyway, she's like, her and Mr. The guy who's in charge of medicine, another art history too. Mr. Otten. Him and her were really classes.
Come on.
Yeah, no, that was I remember there was this new person who actually he switched out. And he's like, I'm a safety teacher and a English teacher. He has a master's. Oh no, he has a PhD and all this stuff.
I would teach myself and I don't know if I'll ever get a doctorate, but anyway, I've always thought that. Then you call me doctor?
Hello.
I guess I understood that we could do one thing is that you spend the whole last time.
Yeah, I'm in the middle, I'm like, I'm not like that, but like, what do they need that you go do? You know what you need.
What do you major in?
I'm an history major. Yeah, actually, I got my AA in 2019. I transferred. Something happened with one class that I ended up passing.
Okay. Sorry about that. Took a little bit longer. Okay, ladies and gentlemen, let's give you guys some more information so you can do your what? Homework. Okay, so here we go. I'm going to give you guys another definition of, well, okay. Let's ask you guys, what do you guys think of the word what? Odds. Have you ever heard the word odds by any chance? Now, if you gamble, this is really the language of gambling. Like if you go to Vegas, they never talk about probability. What they talk about is odds. In other words, odds is another way we could measure what? Chance. Okay? Odds is another way to measure chance. But to be specific, we have the definition of what's called odds for an event E. That's n of E to n of non-E. And this is a ratio, meaning this symbol here, this colon, represents the word 2. So it's actually, again, it's a ratio. And if he said to me, what's a ratio? Well, it's relating to numbers. They call that A to B. There's a ratio there. Okay? But notice the definition. The definition of odds for an event, it's n of E to n of what? Non-E. That's the complement of E. Okay? It's written as a ratio. And it's thought of as really the number of successes to the number of failures. Okay, odds for an event. Number of successes to the number of failures. To measure chance, you're measuring chance, odds for an event, number n of E to n of E and a non-E. And, I'm going to stick again with the marble example to kind of start to talk about this because it's a really a fascinating way to start to think of odds. And I've always said, I can teach everything you need to know about probability from a bag of marbles. And it's one of my favorite examples, but anyway. Okay, so let's give you guys an example here. They're going to say now, instead of a probability, you're going to select a marble again at random. All right, what's the probability of selecting question 1? I'm sorry, not probability. What's the what? Odds for. Selecting, I'm going to say a blue marble. Okay, so you might say, how am I supposed to answer that question? By using your what? Definition. And you say, well, how do you use that? Well, you need to know the number of blue marbles to the number of what? Non-blue marbles. How many blue to how many what? Non-blue. Okay, you guys okay with that? So, tell me, all you got to know is the difference between being blue and non-blue. And then all you got to do is count. How many blue marbles are there? 5. Good. So we say 5. What is that? Colon. And then how many marbles are not blue? 17. Okay, ladies and gentlemen, this is thought of as 5 successes. 5 what? successes to 17 failures. Because this colon is the word what? To. Okay, so I want to kind of emphasize this. This here, there's going to be two numbers again. It's very simple. Use your definition. 5 successes to every what? 17 failures. Now I want to say something about this because these are kind of this is asking for odds now. Success to failures, right? I would say you want to consider maybe unitize. Unitize the successes. So whenever you have a ratio, you know what you can do with a ratio? You can actually divide both of those numbers by the same number. And so when I say unitize our successes here, you're going to take this so it has a little bit more meaning for you. How many successes are there here? 5? Okay. So what do you think the word unitize? You ever hear the word unitize? What does that mean? The word unit means what? So you can divide the first number by 5, the second number by 5. What do you get? 1, 2. What's 17 divided by 5? What's 17 divided by 5 now? 3.4. So let me demonstrate to you guys why you may want to consider and unitizing your odds, okay? It's a very important thing because very often you see the same ratio written this way, 1 to 3.4. Now you say, why do you use the word 1? Because you think of it in terms of whole numbers. There's one success to 3.4 what? Failures. So I'm very big on the idea of unitizing your odds because if you say to somebody, hey, there's 5 successes to 17 failures, you kind of don't know what to do with that. But if you say, hey, guess what? There's 1 success to every what? 3.4 failures. Now it makes a little bit more sense. Unitizing is a big deal, and unitizing is everywhere because you want to think of it in terms of that whole number 1. Yes?
So are we always gonna unitize or only when you put it on the?
I'm always going to ask you to unitize personally. Because it's kind of like thinking of probability. Yes, you could give the decimal, right? But when you talk to people, it doesn't make any sense to them unless you say percent. Like the media doesn't tell you, hey, there's a 0.5 chance of rain today. 0.5 is really what? 50%. So in language and communication, in order for people to be able to absorb it, to taste it, to think about it, right? Unitizing is the way to go in terms of odds. Percent is the language communication of probability. So, you might say, oh, the odds for success or odds for selecting blue, because that's what this is. It's 1 to 3.4. So there's 1 success to every 3.4 failures. Now, that's not 3 failures. That's not 4 failures. That's 3.4. It's a decimal. So it's a way to communicate, and it's a way to make sense to people who maybe don't understand what you're talking about. Now, ladies and gentlemen, I did something with this bill I'll be talking about in Sacramento this weekend. And the Monday I'm taking, I'm not taking the day off. I'm working in Sacramento. But part of what I did prior is I did a lot of, I did it for the state. I did some state work where I computed, due to AB 1705, AB 705, putting people in transfer level courses without the option. I'm saying without an option to take any other courses. If somebody wants to take their chances, go right ahead. But if you can't succeed, we have options for you. They want to remove the options. And that's going to happen as early as June. July, sorry. So, I'm dealing with some of that situation now, and I'll be, talking to some legislators, blah, 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 blah. I'll be on whatever I'm on, right? Doing some stuff. But what I'm saying to people, I made a presentation where I took the data from the state for what's called AB 705 and what happened before it and what happened after in terms of what they call throughput, success to failure. And I looked at various demographics, and I'll share some of that stuff with you guys because it's meaningful probability and statistics. This is what you really do. And as a consequence, I've been, I don't know how to put this. I've been selected for a lot of things now, known throughout the state. The author of the bill knows me, the special interests know who I am. It's a whole thing, okay? And so I made a presentation based on success to failure. And, I'm gonna look at some of the success to failure information I have. I just used this definition, and the world just lost it and said, oh God, that Mr. Judge is a what? He's a genius. It's like, no, I'm using elementary statistics, folks. The rest of you are what? Having some issues. You guys know what I'm saying? It's not that I'm a genius. It may mean something else. So, and so let me find some of the unit ratios. Where are you? Oh, where are you? Oh, I think they're here. Sorry about that. They're here. I knew I seen them somewhere. Sticking them up. All right, various colleges. Ooh, East LA. Add this. Ooh, our campus. You know what I did? Where are you? I want to move you, picture. Okay. Here's what I did, and I'm going to have you guys compute this yourself. You know the Titanic, you know what the mortality rate was on the Titanic?
2,200.
Well, in terms of odds, we can compute the odds for surviving on the Titanic, okay? So let me do that first, okay? So if I go back, just to kind of give you guys a brief demonstration of the so-called genius of Mr. Judge. He's not even a genius. He's just using what I'm teaching. People flip. What's the odds for surviving the Titanic? What's the definition? It's the number who what? Survive to the number who do not survive. What's not surviving? You guys remember the Titanic data? Go back and take a look. Weren't they 706 survivors? Say yes. How many people died?
15,000.
Is it 15, 17? You guys have that in your notes. Can you guys unitize the number of survivors? Say yes. What do you guys want to do? We want to make sense of this in terms of unit ratios. So what I'm saying to you guys, on the Titanic, there's one survivor to how many non-survivors? 15, 17 divided by 706. Is that right? This is about, let's go to the nearest tenths. Let's keep it simple. 2.1. Okay? Now, what does this mean? This means there's one what? Survivor to 2.1 what? Non-survivors. That should have some meaning for you guys. For every person who survived, how many people did not? 2.1. You guys with me on that? Easy breezy, lemon squeezy? This is unit ratios. This essentially is, I should say to you, middle school math. I don't say it to be mean. I say it for a point. 1 survivor to what? 2.19 survivors. So what I did here in some of this presentation that got known throughout the state and made me famous or infamous, I have no idea. I took the various campuses in our district and I looked at what I call the survival rate for a transfer level math class using the data on what's called the State Chancellor's dashboard, which isn't accurate, by the way, but that's another story. And what I did was for various campuses, for various demographics, people of color, I looked at the survival rate. In other words, due to this bill, transfer level math courses amongst which group? Hispanic students. There's what? 1 success to every what? 3.6 non-successes. And that doesn't include the drops before census. This is data taken in 2018, 2019. 2018, 2019. 2019, when they did AB 705, I want to give a glimpse of what you can expect with AB 1705. And for this campus, 1 success to every 3.6 non-successes. This is using district data, which is actually even flawed. It's probably worse. And it doesn't include drops before census. And that's amongst what group of students? Hispanic students. Now, why do you guys think I have the AB 1705 mortality rate, and why do you guys think I have the Titanic? You know what I said? You know what your conclusion is as you actually compare this? What's your conclusion?
Survival rate is worse than the survival rate of the Titanic?
That's the whole point. You're more likely to survive the Titanic than you are to survive a transfer level math class that year, 2019, the year of AB 705, when they opened the floodgates. That's the analysis. That's the point. That's why you guys learn probability, odds, you unitize. You're looking at it in action. This is 10th grade math, 10th grade reasoning. I'm sorry, not 10th grade. Middle school math, middle school reasoning. That's all I did. Now, why do you think I did it this way? Of course, I teach these definitions. We use it. That's the point. But if you're going to talk to politicians and people, they have to understand it from a very simple perspective. You can't go in there, look at all this data, look at the percents. If you do that, you're done. Trust me on that. You'll lose people. When I have to look at data and presentations, I don't want to. I get sick. Because a lot of times the people that explain it can't really explain it. That's why you get sick. So when you keep it simple, like I just did here, I computed all these ratios. For every survivor, 3.6 non-survivors on the AB 1705 mortality rate. That's why I have the Titanics. So I compared it to this ratio I just gave you guys that we computed together. Yes, you're more likely to survive the Titanic than you are that transfer level math class. That's the deal. Yes.
Do you have any data for white students?
Yes. In fact, I'm thinking of, on Monday when I'm not here, I'm thinking of sending you that lecture. It's interesting. I do have a lot of data. I was looking at it last night with a meeting, but yeah. White and Asian students are pretty much not affected. Asian students, I should say, are not affected. White students are slightly affected. Who's really affected?
Black students?
Black students and Hispanic students. So you might say, hey, Mr. Judge, what are you showing? I'm showing that this is a disenfranchising exercise. I made the claim that, you know what? You don't call the Titanic a successful cruise. Why would you call this a successful bill? You see my point? And all I argued for was to give students a choice. I didn't argue to place students anywhere, I just said give them a choice. So you can decide, hey, I think I have an issue maybe I should take some other class that helps me, but they're now going to remove that option for you. What are you going to do then? You guys see what I'm saying? I have a calculus 2. I told you guys, I got a calculus student. Sorry, she's a trig student. She took high school AP calculus, got an A. The whole class got an A. I think she said she gave a couple of basketball players got a B. The class was taught by coach. Everybody failed the AP exam. I set up a meeting with the school and I said, hey, you know what we're going to do? We should send an instructor over to that high school. That's Torres High School down the street. It's not far. It's a STEM academy, for Christ's sake. Send a calculus instructor there. We're going to send one, right? Teach those students how to do calculus. Not done by coach. Someone who's qualified. You know what the school's only concerned with? Who's the student? We want to talk to her. Question is why? Why do you think they want to talk to her? Yes. Shh, don't talk to her. Shh, keep it quiet.
What classes are they trying to push for the dual student now?
They're like a lot of like psychology. I think they're offering Chicano studies, psychology. It's a lot of like, it's not the STEM courses or the math courses at all. It's not. It's a lot of the other stuff. So it's kind of rare to offer a dual enrolled math course. So all they're concerned with was who's the student is so we can talk to her. I said, no, you're not going to talk to her. You know what I'm going to do? I'm going to record her, interview her anonymously. We're going to put it on the website. We're going to cause a hell of a lot of trouble. You know what I'm saying? Because being bad feels what? Pretty good. I'm just joking. I'm joking about the bad feels good. But I'm thinking, yeah, put this what out there, some of these interviews. So I'll be where? I'll be in Sacramento, so you guys know. And not only that, and I'm gonna probably share with you, send you guys a video in Canvas to watch on this stuff. You could use your definition of odds 4 and unitize, like I showed you guys. And then you can see all the slides I made. All right, and then, like I said, I usually have given people tests on that stuff. You guys can use the real data. And now the district doesn't want to give me real data anymore. It's like, oh crap, the guy's using it as part of his lecture. I told him I would. This is public information. And this is statistics. And it's statistics in action, how you really use it. So I'm going to tell everybody, I don't teach my students to do things the way you guys are doing it. So you guys are doing stuff wrong. And their data, ladies and gentlemen, I have to say, there's more to the story. You would not believe it. You'd not believe it. But it's sad because I do think students are going to be disenfranchised. And what makes me angry is that if I went to school today, I wouldn't even bothered. Because where I started is in geometry. And then I took intermediate algebra, and then I took trig, and then I took pre-calculus and calculus. They would have put me straight into a transfer level math class. I wasn't ready. In fact, math and English, I wasn't ready. I was going to join the Marines and get out of here is what I was going to do. Eventually got there. That's another story. But the deal is, ladies and gentlemen, this is the truth. If I went to school today, I wouldn't go. There's not a place for me here under this scenario. And that's the truth. And, this is what I'll be talking about, on Sunday and Monday. And, we're going to keep fighting. I'm going to keep fighting. And, I'm going to keep fighting because that's what I do. It's the way you got to do it, ladies and gentlemen. And, so pray for me. I don't ask for anything other than prayers. Because I believe in prayers. Pray I'm successful. And successful for who? It's not for me. Trust me on that. Successful for you. Your kids, your brother, your parents, your cousin, successful for you guys. And that's it. That's all I care about. All right, so I'll send you guys, stay close to Canvas. I'll send you guys something to kind of work on, right? I got to create that too. And you know, I'm going to go pick up my laptop now. I got an email. Yes.
So there's no class on Monday, or?
There's not going to be a class on Monday, but I can send you a video class. Because I have about 3 years of lectures recorded. So I look in the can and I go, okay, maybe this is a good learning opportunity for all of us. And I might just send you, some of the stuff. I got to look at what I have, and I got to think about what I'm going to send you. But I'm going to do that for all my classes. You know, so they don't have a day off. They got to what? Work. Because working's good. I'm telling you guys, you got to learn that lesson. Your life just started working, in all honesty. And when you work and you put that effort in, and you learn and you keep pushing the same way you see me, you'll get somewhere. You'll move. If you don't do it, you won't move. You know, trust me on this. You know, the world isn't nice. The world is cruel. It's not nice. You do have to have some skill sets. You do have to do this, because if you don't, they're going to eat you alive. And this doesn't make me a genius talking about middle school math, for Christ's sake. It's middle school. I'm not a genius. I just work. Okay, you guys. We'll see you guys in a week. Take care. Stay safe. Have a wonderful weekend.